Let us take example. If f is a relation from R to R, where R is set of real numbers and is defined as f of x is equal to x plus 1, then f is what? We have been asked what is f. Now you understood what is a real number. So a real number means that it's all the numbers, the decimal numbers and even the whole numbers. Okay, so that are the real numbers. So moreover, it is the collection of all the numbers. That is the real number. And now we have been given that. So here this is a real number, that is R. It has a relation with another real number R, such that this relation is x plus 1. F of x is equal to x plus 1. That means if f is 1, here it is 1, then it is 2. If it is 2, then here it is 3. If it is 0 here, then it will be 1 here. If it is 0.5 here, then it will be 1.5 here, like that. All right. So what will be this relation? Certainly this relation is 1 to 1. That is, one element is mapping with only one element. Certainly it is 1 to 1. Okay. Now, and what type of relation it is? Can we say that all the elements in R will be mapped? If all the elements, that is all here, all to all is mapping, then it is called as onto. Moreover, real numbers, we can say that there exists some real number into this, let's say f, and this is, let's say, g. There exists some real number in f which always map to some real number in R, in g. Therefore, we can say that here all numbers are mapping with all numbers. Therefore, this is also the onto. So what type of relation it is?
Bijective.
Huh. Injective means which type of relation? 1 to 1 is called as?
1 to 1 and onto.
Yes, 1 to 1 and onto. That is injective and surjective. So we can say that the C option, injective and surjective. 1 to 1 and onto. And that is also called as bijective. But bijective option is not given here. So our correct option is injective and surjective. Now the next question, if A is equal to B is equal to 1, 2, 3, 4 and f is a function from A to B given by these pairs, then f is. So we have been given this. All right. So let us draw. So this is A. This is B. A is 1, 2, 3, 4. B is also 1, 2, 3, 4. By this pair, we can represent a relation. That is, we have 1 to 1. So that means we have a relation from 1 to 1. Then 2 to 3. So we have a relation from 2 to 3. Then 3 to 4. So we have a relation this. And 4 to 2. This. So what type of function it is? One is mapping with one is mapping with one, so it is 1 to 1. And we see that all
1 to
are
1
mapping, and all is mapping with all.
Onto from
Onto.
Very
Onto.
onto. So it is 1 to 1 and onto. If the relation matrix on a set A is equal to 1, on a set A 1, 2, 3, 4 is given by, then the composite relation R square is given by. Okay, so we have been given R and it is on set 1, 2, 3, 4. So what is R square? R square is nothing but composite relation R square is R dot R. RR is the composite relation. So we have been given R is equal to 1, 3, 2, 1, 3, 4 and 4, 2. So we have a pair from 1 to 3. So we have a pair from 1 to 3. So is there a pair from 3 onwards? 3 onwards? Yes, it is there. So 3 to 4. So what will be RR is 1 to 4. So that will be there. 1 to 4 pair will be there. Now we have a relation from 2 to 1. So is there a relation from 1 onwards? Yes. So 1 to 3 is there. So by this we can add 2 to 3 into this. So 2 to 3 is also there. Now we have a pair from 3 to 4. So is there a pair from 4 onwards? Yes, 4 to 2 is there. So we can add 3 to 2. Now we have a pair from 4 to 2. So is there a pair from 2 onwards? Yes. So 2 to 1. So we can add 4, 1. Right? So therefore RR is these 4 pairs. So 1, 4, 2, 3, 3, 2 and 4, 1. So which one is present? So C. C is the correct answer. Getting a point? 1, 4, 2, 3, 1, 4, 2, 3, 3, 2 and 4, 1. Yes. Which of the following relation on A is an equivalence relation? 1, 3, 5 is an equivalence relation. So what is the definition equivalence? That it should be reflexive, it should be symmetric, and it should be transitive. So let us take it one by one. 1, 3, 3, 1, 5, 5 itself is not reflexive. Therefore, one is A is gone. Let us take B. B is 1, 1, that is reflexive. 2, 2, 2, 2 is there. No, sorry, 3, 2 is not part of the 1, 3, 3, 3, 3 is there. 5, 5, 5, 5 is also there. Now 3, 1 is present. So then 1, 3 is present. 3, 1 is there. To make it symmetric, it must have 1, 3. So is 1, 3 there? 1, 3 is not there here. Therefore, it is not symmetric. It is reflexive, but it is not symmetric. Now let us take the third pair. 1, 1 is present. 3, 3 is present. 5, 5 is present. Now 3, 5 is present and 5, 3 is present. So that makes a reflexive. Okay. And is it a transitive? So we have a relation 3 to 5 and we have a relation 5 to 3. So therefore 3 to 3 pair has to be there and that is there. Therefore it is transitive. So it is reflexive and it is symmetric. Therefore the correct answer is C. If A is equal to 1, 3, 5, 15, 30 and R is a partial order relation defined on set A as R is equal to xy, xy belongs to A and x divides y. That is first number divides the second number. Then Hasse diagram of R is. So is this the correct Hasse diagram? 1 divides 3, that is correct. But does 3 divides 5? No, 3 doesn't divide 5. Therefore, the first Hasse diagram is not correct. Second Hasse diagram, that is 1 divides everyone. That is, it is correctly shown, but it is not complete. Okay, because in this case, 5 also divides 15 and 5 also divides 30. Therefore, this is there. It is only showing half of the diagram. Now let us see the third one. In this case, 1 divides 3, 3 and 5. Okay, 3 and 5 both divides 15. Yes, and 15 divides 30. Therefore, this is correct. In this case, 5 and 30 is not relation shown. Therefore, our correct His diagram is this. Any doubt in this? Okay, next. Now, I have told you in a Hayes diagram what is anti-chain. Suppose we have a Hayes diagram, this, and this, let's say. In this, it is, let's say, A, this is B, this is C, and this is D. Then what is a chain? Chain is that it is a connection from A to B, B to D is a chain. So A, B, D is a chain. Similarly, A, C, D is also chain. A, C, D is chain. But B and D, B and C, they are not related. Okay. Therefore, anti-chain is B and C. Okay. Now let us see here. The Hayes diagram of the partially ordered set A is equal to is given below. The anti-chains are. So which are the anti-chains? ABD. ABD cannot be anti-chain because AB is related. Okay. Therefore, ABD cannot be anti-chain. ADE, ADE, moreover, it is a chain. It is not anti-chain. BC is also not anti-chain. Moreover, it is a chain. DE is also chain. Therefore, it is also not correct. It is not correct. AB, AB is chain, and ED is also a chain. Therefore, this is not correct. Now BD, so BD, yes, it is a anti-chain, and CD is also not chain because they are not related. Therefore, the correct answer is BD and CD.